So with this new lesson here, I'm actually going to be starting with the previous lesson on page 2 and just kind of covering a couple things on labeling our triangle and what we can kind of see based on kind of what we've gone in the past as well as what's coming up in the future here. So here we have a right angle triangle. Now we will know that this is a right angle triangle based on the fact that there is a small box in the corner. Okay? That represents a 90-degree angle, and so it tells us it's a right angle triangle. Also tells us that these two angles add up to 90 degrees. Okay, so that's something that we need to be aware of. Now, when we are doing a question like this, it's sometimes helpful to label all of our corners. So let's say that we label this with A, this one with B, and this with C. Okay, so that we're going to label our corners A, B, and C. It's not going to be overly necessary this year, but it can be a good habit that we come through. We can also label it as X, Y, Z as well, if that would if you like those letters better. Then the final thing that we're going to see, and this is going to be the case in every single one of our triangles, is we're going to see one of our angles, and I'm going to use this one here, one of the other ones. So we have our 90-degree, and then we have two others. One of them is going to have an angle measure or theta there, or it's going to actually have an actual angle. So it may actually have what the measurement of that angle is. Okay, and that is going to be our known angle. This is going to be our unknown angle. Okay, known, unknown. We don't really ever deal with the 90-degree at this point, but we have our known and our unknown angle. Now, from this point here, okay, this is where we're going to label our sides with three new labels that we have never done before, and this is going to be all brand new. The first label that we're going to deal with, and actually this one you may have dealt with in the past, is the one called the hypotenuse. It is the longest side. Okay, I'm just going to do HYP, or you can also just do H if you so please. The HYP tells us for sure it's the hypotenuse and not just the way that you are labeling. Okay, the hypotenuse is the side that is not touching the right angle. Okay, it is across from the right angle. Okay, across from the right angle, not touching. It's also going to always be the longest side. So it's always longest side. That is the hypotenuse. Okay, that is what we're going to label as the hypotenuse. It's always the longest side. It's always across from the C. That one doesn't ever change. The other two that we're going to be taking a look at deal with something called the adjacent and the opposite. Now, the adjacent side, these are the two legs. We talked about the legs being attached to the right angle. Our two legs, the adjacent and the opposite, are based on our angle that we either know or need to find. So we need, in this case here, we need to find this angle, but we'll also get to the point where we know what the angle is. The leg that is touching that one, okay, and I'm just going to do a little arrow like that. It's touching this angle, or it's right between the angle we know and C, is called our adjacent. Okay, and I use a short form ADJ for adjacent. Okay, just to make it a little bit simpler. If you want to use A, you can as well, but again, it could make a little bit of confusion. ADJ will never have any confusion as long as you write neat enough. Okay, so that one's going to be the adjacent side. It is touching the angle. Think of it, what is adjacent to you is right beside you. It's right close. Okay. Now I know with COVID, nothing is close to us, right? Yeah. But we have this side here, which would be touching the unknown angle or a known angle, as well as our right angle that we have there. That means that the other side is going to be our opposite. This is the side that is not touching the angle. Okay, it's away from the given angle that we have. So it's away from B in this case here. So that is our opposite side. Now the way we label this is very important as we move into our next part of the lesson. I'm just going to slide over to that next part of the lesson, and that is using tangent ratio. Okay, using tangent ratio. Now, so I'm sliding right into this here. I'm not going to even break the video. A ratio, okay, and it's important that we understand this. A ratio is a comparison. Compare. Let's get that right there. The sun. There we go. Of any two values. At any two values. Now, that is across the board. We'll deal with ratios later on and comparisons later on as well in other courses. But we can kind of think of it as it is a comparison of any two values. It can be shown using a fraction. okay, which is what we're going to do in this class. Okay, so a comparison of one value over another value, it's going to be a fraction. In trigonometry, using our using triangles, we use a number of different ratios. One of the ratios that we use is one called the tangent ratio. Okay, this is the tangent ratio, and we're going to shorten it to tan for ease sake. And that is a ratio which compares the adjacent side, or the adjacent and the opposite sides of a triangle. And it's specifically for the opposite and the adjacent sides of a right angle triangle. And we can only do this with right angle triangles, and it's very important that we know that. The ratio that we have is this right here. Tan of theta, and we won't worry too much about that right now. We'll talk about that in a little bit. But the ratio is the opposite side over the adjacent side. Okay, it's the opposite side over the adjacent side. When we talk about the tan ratio in this case here, we will understand that it represents a triangle that has the opposite side over the adjacent side. We can simplify this off a little bit, and I'm just going to kind of use our short forms for this. Our tangent ratio, and I'm going to say tan and tangent together, it's kind of in combined. Is this just a shortened form? Opposite over adjacent, we can think of as opposite OPP over ADJ. So our tan ratio for every right angle triangle is the opposite side over the adjacent side. This ratio, sorry, let me just get a different color here. As you know, I like to change colors. The ratio can be written as either a fraction or as a decimal, which has been rounded to 2 decimal places. Now again, as we know, the decimal isn't exact. Okay, the decimal won't be exact, so the fraction is exact. So it's a little nicer to do the fraction, but if you want to do a decimal, you can round it to 2 decimal places or keep it as that exact decimal that we get. So let's take a look here at finding the tan ratios. Let's look at angle A, and I'm going to do a couple different things here. So I'm going to let's close that off first. All right. So in this case here, we want to look at angle A. Angle A is right here. So that means that we are now dealing with, and I'm going to do this one in red. I'm going to do 2 different colors on the same triangle. We are looking at this angle right here. When we talk about this angle right here, this side here is our opposite side. This one is the hypotenuse, it's the longest side. And this one is the adjacent side. Okay, now that's because it's touching the angle, and this side is not touching the angle. So that's why it's the opposite, that's why it's adjacent. And this one here is across from the 90 degrees, so it's our hypotenuse. Now for our angle, okay, remember it's always opposite over adjacent. So for our A, our tan ratio, do it as a math type here. Our tan ratio is our opposite side, which was 7, over our adjacent side, which is 11. Now, if we want to change that into a decimal, we can do that as well, just 7 divided by 11. I'm not going to worry about that because that's inaccurate. It's going to be rounded. I'm going to leave it as a fraction, 7 divided by 11. Okay. Now, again, later on, we will end up dividing, but I'll show you what we do with that and how it's important that we keep everything as exact as possible. Now, our tan ratio for C is different, okay? And that is because our ratio is actually dependent on the angle here. So the angle C, I'm going to do in blue. Hypotenuse is still the same. That one doesn't change. But now this side here is our adjacent, and this side here is our opposite. So our opposite and our adjacent switch because of those two. Okay, so the adjacent and opposite switch because of those two. So that means that our tan ratio for C is different from A. Our tan ratio for C will be, and I'm just going to get my math type here, opposite over adjacent, so it will be 11 over 7. Okay, it's 11 over 7. So that is where, that is how things change. Okay, we flip it around. So that's how we find the ratios. Okay, for A, it's 7 over 11. For C, it's 11 over 7 because our opposite and adjacent sides switch because it is different angles or a different piece that we are trying to find. So it's important to remember that it's not going to be the same for every single triangle.